there is a time for discussion, and I kind of wanted to just break it up into two brief components. The first, I was thinking of, perhaps there are other people around the call who want to just give a shout out to work that they've been doing or point to other work that's been done relevant to the HCA. So I'll just unmute everyone from my end. And just allow people to speak, unmute themselves and speak if they want to just shout out to any particular package.
They're renovating. This is very big.
Or other work that they're doing.
Probably bigger than these pictures are more than
well, I guess maybe if I may.
Yeah.
Does the sound come through okay?
Yeah.
Okay, perfect. So yeah, I just wanted to give a quick shout out on two packages. I mean, I know there's like 2 or 3 packages for gene sets at the moment that are being developed, Kyla being one of them, and I'm really looking forward to trying more of gene sets. So I've recently given a shout out to a little advertising for Unisets if anyone wants to try it. I can just link in the documentation after that. So it's just an alternative full S4 nearly representation of gene sets. But perhaps more importantly, something I've worked with Rob Azmekita in Rafael Gotardo's group was a package called Hancock for the famous signatures for gene sets. And I've talked a little bit with Vince about this, about representation of gene signature, and essentially most importantly metadata on the genes, on the signature, and on the relation between gene and signature, which is one of the motivation for Kyla's gene set and my Uniset to store that information. It's not just about knowing which gene describes which cell type, but how does it describe each cell type, and maybe filling in the gap that's currently that's still left despite GSCA base. So there are those 2 packages, Unisets and Hancock, and they're progressing slowly on the side of a ton of other projects that I'm dealing with locally. But again, I'll send the 2 links again back in the document. If anyone wants to like come in, look at it, and say, all right, that's definitely going down the wrong road, or maybe that's a decent idea, but this or that could be improved, I'm more than happy then to take the feedback. That's why I love Bioconductor, developing on GitHub, and having all the issues open, more issues than commits usually. So that's the idea.
That's great. Thanks, Kevin. Was there someone who wanted to say something about tree summarized experiment?
I didn't hear well this one.
I was wondering if someone on the call wants to say something about tree summarized experiment.
Oh, right. Sorry. Yeah.
Or other topics? Maybe we could try just opening up the floor for questions for any of the speakers.
Martin, this is Stephanie. Sorry.
How about Stephanie?
I just wanted to ask about use cases for the browser, let's say. Do we know how many people are using it and what's coming through it and how it could relate to downstream analysis with the tools that have been described?
The browser, essentially what we're just trying to do is provide an interface to access the files that are on the browser. I mean, right now we have the ability to run this that has been passed on to Marcel's HCA matrix package. And I suppose in general, this also gives us the ability to pull any file from the HCA install list as well. I guess that's what I was trying to go for. I'm not sure if you have any recommended use cases for it, but any other recommended use cases for it, that is.
Well, I'm just trying to get a feel. Maybe use case was the wrong term, but do we have users, and do we see that you can actually learn from the HCA through these utilities?
Have users. I mean, we have people using the package. I suppose you're asking about the representation of the actual HCA browser object. That has been a point of discussion, I guess, before about how to represent this data so that it's actually more clear to the users. I suppose it's somewhat challenging just because of the large amount of, I guess we're trying to use tables and the large amount of data that's actually inside of it. We also have to flatten a lot of the data just because it has different dimensionality throughout. So there's been a lot of challenges there. I would say that the current table representation does work fine. At least I guess in my opinion, it seems to allow for some discovery, although again, it may be a bit overwhelming. So I suppose if you would have any suggestions for it to increase usability, that would be very helpful.
I think it's very challenging to navigate the HCA data. It's so rich and complicated.
Yeah, I mean, my question was, what is the other way? I mean, except the Bioconductor package, what are other ways of exploring the HCA data, except the preview data set?
There's a Python package called DC. I think it's called DCP. It's called DCP CSS. No, that's not it. It's a package of HCA, I think. DCP HCA, sorry. That allows for a similar functionality, I suppose, but they use direct JSON queries, so that's maybe not as useful to the user since they would need to actually have knowledge of the entire JSON schema for the HCA. There's a web site for the HCA has that also does facilitate searching for it, although this also doesn't seem to quite capture the richness of the entire HCA as well, since it only seems to let you search across some parameters. I guess common parameters, but only some.
Marcus Kinsella is on the call, and he posted a link into the chat to the DCP CLI. I don't know, Marcus, if you had anything to contribute. You're maybe more on the inside of the HCA than us.
I think you mostly covered it. There's basically that Python package, and sort of like the API that wraps, and then the website that people look at.
Yeah, it's quite challenging. Stephanie, did you say something?
Sure. I had a question to anybody on the call. So within the world of analyzing single cell data, are there emerging technologies or data types, single cell data types, that the current bioconductor infrastructure is insufficient for, or are there areas that that somebody might think that we should be focusing on moving forward? Aaron, are you saying something?
Sorry, I muted Aaron because he had a little bit of feedback. There you go. Fire away.
Yes, spatial mapping, imaging, the MERFISH and SeqFish stuff. That's basically, I mean, we've only got basically one imaging package, and that's a EB image, right? So that would be the major sort of gap in the future technologies. Having said that, those technologies have been a long time coming as well. So it's not like we've had a lot of data to play around with. I mean, I remember I was being promised this data 3 years ago, and here we are. But yeah, so in terms of sort of, I'm not so concerned about pre-processing that data, because the CZI guys have this starfish thing that looks pretty good. So that's sort of like the equivalent to alignment for us. But the sort of downstream analyses of imaging data would be the next logical step in terms of the statistical methods that are needed.
So, and this is Raphael speaking. Can you hear me?
Yes.
Yeah, just to follow up, I mean, I guess the question is, do we even want to go into imaging? I mean, there's EV image, as you've said, but do we think that it's realistic to think that we can do things in that space, given, maybe the limitations of art to some extent, or the lack of real support for image analysis? And maybe one way to think about that, and that's something that, might be a better investment, is about downstream analysis. So once you've processed your images, right, so more modeling type things from the derived data, or the sort of pre-processed images where you've already extracted the features in a way.
Yeah,
Well,
that's
I think
exactly what I was thinking about.
I think in general we need better capabilities in R for dealing with high throughput images. I mean, sort of across the thing. I totally see where you're coming from, Raphael, that you don't want to start too far back in the stack, and you want to focus on where you can make the biggest contributions, right? But if you take a step back, I think we should play a bigger role. We ought to play a bigger role in the high throughput imaging world. And achieving that that's not a small thing, right? That's not the same as just adding in a little bit of additional support for similar yet slightly different assay, right?
Yeah, I guess my point of view there is that one is that there are a lot of, I mean, there's a couple of tools that do that to some extent, right? Where, Image or Cell Profiler that people have been working on for years and years and years. And also that process can be pretty manual to some extent. So you kind of need to have sort of a pretty good user interface for doing that. So I'm not saying we shouldn't do it, but that's certainly a big investment, and I don't know if that's the best return we can get on the investment.
I think that's a fair statement. I'm, for example, not offering to do it myself. Like, I agree with you that the current, it seems to me, without ever having done it, that the current kind of image stuff has a lot of manual overhead. It has little data sharing. It has tons of issues. But that's perhaps stuff where, we could, I look at all of this manual intervention they do, and it seems like crazy, right? I mean, why do they have to do that? But that's a big problem. Like, I'm just taking the 1,000-foot view visits that I think we ought to be better at the high throughput imaging.
Yeah.
I mean, it's a whole area that I think is only going to increase in importance in biology, and we are not really big players in it. Whether or not we want to come in and do modeling after Cell Profiler, or whether we want to compete with Cell Profiler, that is really up to the people who is going to undertake that task, right? But I mean, do I think that the project should be better at high throughput imaging? Absolutely. Like, I mean, if somehow magically it could appear, right?
So maybe one way to get started is better interfacing with these software packages, right? So how can we easily, and maybe there's already such things, I just don't know about it, but, reading common file formats or outputs from, major sort of software imaging platforms, and then maybe playing with these data. And maybe that's kind of an easy way to do it. And then, depending on usage or whatnot, we can decide where to go next. But I think this would be sort of the low-hanging fruit at least.
Absolutely.
Are there other things from, in answer to Stephanie's question, other directions that one would be likely to benefit from taking?
I mean, I'm a little bit interested in the single-cell epigenomic stuff, and I think a lot of it fits into the pipelines we have, right? But the data is a little bit different because typically the number of rows is not like, in the tens of thousands genes, but, far many more, potentially many more loci across the genome. But I mean, to a first approximation, it should just fit into our things. I think some of the algorithms we're dealing with is gonna run into potential problems when you switch from having, say, 30,000 rows to having 1 million rows, right? But that's way more approachable than dealing with the high throughput imaging.
Yeah, I second that. I mean, I think there's going to be a lot more need for these kinds of approaches. And also, there's been very little modeling of single-cell epigenomic data. I mean, there's been stuff, but it's not super statistically, I mean, I don't want to say rigorous, but elaborated. And so maybe there's room there to improve because there might be more and more models that people will think about how to analyze these data. And obviously the size of the data sets will keep increasing. So that's only something to think about.
There's also, in all honesty, been less data available, right? But that's changing.
That's right. No, absolutely. But that will change for sure.
I think we're coming close to the end of our allotted time. And if there are any final questions or comments, maybe I'll just again extend a great thanks for everyone for participating and for the really interesting work that's been done and the opportunity in some ways provided by the HCA to explore areas of Bioconductor that definitely needed some scalability issues, and for the creative solutions that you guys have all been working on and contributing. So I hope to see you all at BioC 2019 New York City, if not before. And thanks everyone for joining today. I think the video symposium went really well, and it's great to have been able to share your results. Thanks very much. See you all.
Thank you, Martin, for organizing.
Bye.
Thank you. See you.
Thank you.